In this lesson, we're going to go over angles of polygons. So we're going to talk about interior and exterior angles. And so we're going to start off with just a little bit of vocabulary. So going over some vocabulary we need to know, we have our vertices. Okay, and so a vertice is just going to be a point on a polygon where the sides are going to meet. Okay, then we have a diagonal, which is just going to be a segment that will connect two non-consecutive vertices. So two vertices that are not next to each other. And then lastly, we have our regular polygon. And so this is going to be a polygon that is both equilateral and equal angular. So that just means all of my sides are congruent and all of my angles are going to be congruent. All right, so we're going to start off actually with a little bit of an explore. Okay, so we are going to complete the table below and look for a pattern to find the sum of any polygon. All right, so the first polygon we're going to talk about is going to be a quadrilateral. And so we have a picture here of a quadrilateral. And that's just going to be a four-sided shape. And so here we have a picture, and then let's look at filling in our number of sides, which, like I said, is just going to be 4. And so they're asking for the number of triangles. So the way you figure out how many triangles is you're going to start at a vertice, and then you are going to draw a diagonal from that vertice that you've chosen. It doesn't matter where, but you got to then start from that same point every single time, and then just draw a diagonal or as many diagonals as you can. And so for this one here, it's not going to be perfect, but that would be my example of my diagonal. And I can see that I'm going to have 1, 2 triangles. Okay, and so the sum of the angle measures, well, keep in mind, remember, in a triangle, you have, the sum is going to be 180 degrees. And so what I'm going to do is I'm going to take that 180 degrees, and I'm going to multiply it by the number of triangles that I have. And so I'm going to get 360 degrees for that sum. Okay, then let's move into our pentagons. Okay, so we have a pentagon is just going to have 5 sides. So I'm going to fill in here. My number of sides is 5. And so to find my number of triangles, I'm going to just pick a vertice, and I'm just going to use this one right here to start. And I'm going to draw all the diagonals that I can from that same vertice. Like I said, doesn't matter where you pick to start from, it just means you've got to then start from that same point to draw all of your diagonals. So I've got 1 diagonal and then 2. So the number of triangles is going to be 1, 2, 3. And so to find the sum of the angle measures, I'm going to multiply 180 degrees by 3. And that is going to give me 540 degrees. Okay, then moving into our hexagon. Okay, hexagon is going to be a 6-sided figure. So drawing all of my diagonals, start up here. I'm going to draw 1 diagonal, then 2, and like I said, it's not going to be perfect, but you get the idea, and then 3. So I have 4 different triangles in that hexagon, and so I'm going to then just take my sum of a triangle and multiply by 4. And I'm going to get 720 degrees. Okay, so the last one we have is going to be our octagon. And so an octagon is going to have 8 sides. And so you might have already kind of picked up on the pattern. It is a little different since we are skipping a number of sides. But let's look and see, starting here at this vertice, how many diagonals I can draw. So I've got 1, 2, 3, 4, and then 5. So that's going to give me 1, 2, 3, 4, 5, 6 triangles. Okay, like I said, I did skip a number of sides here. That's why my pattern's off a little bit. And then I'm just going to multiply that by 180 to figure out my sum of my angle measures, which is going to be 1080 degrees. All right, so like I said, we're coming up with a pattern. So obviously we're not going to have a picture here. So I'm going to just kind of scribble through that. But for our n-gon, okay, so this just means we have n amount of sides. So the number of sides is going to be n. A lot of times that obviously that's going to be a number there. The few that we do have names for are like you see here, my quadrilateral, my pentagon, my hexagon, my octagon. There's a few others, but once we get to a point, we do start just calling it n-gon, which would be replaced with a number. So for example, 23-gon. Okay, and so looking here, if we look up above, we can see that there's a pattern. We go from 4 sides to 2 triangles, 5 sides to 3 triangles, 6 sides, 4 triangles. I'm noticing that every single time here, I'm subtracting 2. So n minus 2 will tell me how many triangles I have. And so to find the sum, we would just multiply that by 180, and you get your answer. Okay, so now let's move on to our finding the sum of the exterior angles. Okay, so this is another one where we've kind of got a little bit of an explore, and then we'll fill it in officially below. Okay, but looking here, we are going to find the sum using this picture. And something that's going to help me is the fact that if I notice right here that we have these exterior angles, and if you remember these exterior angles here, they are going to be a linear pair with that interior angle. So that just means that they're forming 180 degree angles. And so we can subtract the angle we know, and that will leave us with our exterior angle, the one we're missing. So that's what I'm going to do. So I'm going to take 180 minus 124, and that's going to give me 56 degrees for that missing angle. Okay. Then over here, I'm going to take 180 minus 76, and I'll be left with 104 degrees for this exterior angle. Then down here, I'm going to take 180 minus that 89, and I am left with 91 degrees. Okay, and then for my final one, I'm going to take 180 minus 71. That's going to leave me with 109 degrees. Okay, so since we are finding the sum, I'm going to add every single one of those exterior angles that I just got. So 56 plus the 104 plus 91 and the 109. So I get 6 plus 4 gives me 10, then 11, and then adding that 9 to it, I'm going to get 20. So I'm going to put my 0 and then bring my 2 over here. We get 2 plus 5 is 7. plus the 9 is going to give me 16. So carrying over that 1, I get 1, 2, 3. So I got that my sum is 360 degrees. Okay, so now let's look at the second one. So in this picture here, we had a quadrilateral. We're trying to see if there's a pattern with comparing these two. And so in this one, we are going to be dealing with 1, 2, 3, 4, 5, 6. We got a hexagon here. So we're going to do the exact same thing, okay? I'm going to subtract each one of my angles, my interior angles, from 180 to find that exterior angle. So I'm going to start off with that 129. So 180 minus 129. It's going to give me 51 degrees. Okay, and then I'll work my way around this way. We got 180 minus 115 is going to give me, we've got 65 degrees. Then 180 minus 117 is going to give me 63 degrees. Okay, 180 minus 123 will give me 57. Then I'm going to have 180 minus 112. I'll get 68. And then for my final angle here, we've got 180 minus 124. And I'm going to be left with 56 degrees. All right, so now that I've found all 6 of my exterior angles, I'm going to add them together. So we'll start off with that 51 plus 56 plus 68, 57, 63, and then 65. All right, so adding these together, we're going to get 1 plus 6 gives me 7, plus 8 is going to give me 15. Then adding a 7 to that is going to give me 22. Plus 3 will give me 25. And then adding a 5 to that will give me 30. So I'm going to have a 0 down here and 3 up here. Then adding this together, we're going to get 3 plus 5 gives me 8. Plus another 5 will give me 13. Plus 6 will give me 19. Plus 5 gives me 24. Plus 6 will give me 30. And then another 6 will give me 36. So my sum for this one is 360 degrees again. So we've kind of noticed a pattern here based off those two. You can do more, but you will then realize that the sum of your exterior angles will always be 360 degrees. Okay, so let's come down here and let's fill in these theorems. So the first one we have is stating that the polygon angle sum theorem, which is the sum of the measures of the angles of a n-gon is just going to be, and this is what we said earlier, so the sum is going to be that n minus 2 times 180. Then for the polygon exterior angle sum theorem, we have that the sum of the measures of the exterior angles of a polygon, one at each vertex, is going to be 360 degrees. Okay, so down below we have some more vocabulary. So we have here that a polygon is a closed plane figure with at least 3 sides that are going to be segments. Okay, the sides intersect only at their endpoints. And we have no 2 adjacent sides. So remember that word adjacent just means that they are next to each other, are going to be collinear. So that word just means that they're forming a straight line. All right, so you can see here we have some examples. We have an example of a polygon and an example of what a polygon is not going to look like. Okay, so noticing the first one, the figure is closed off, no openings. We have no kind of lines continuing past where they intersect. Whereas over here on the other side where we have our non-examples, you'll see we have this hole in this picture. That's why this one's not going to work. And then here we have this crisscrossing over where these two meet. You'll see that they're continuing past that. And so really we have our 2 separate polygons here. Okay, we have this quadrilateral up top with this triangle down below, which is why this is not just a polygon, it would be multiple. All right, so now let's look over at some other vocabulary that we have. We're going to start off with our convex polygon. A convex polygon does not have diagonal points outside of, let me actually highlight, does not, outside of the polygon. Okay, so looking at this picture here, they have drawn all diagonals, and you'll notice that every single one of those dashed lines is going to be inside of the polygon. None of them will be outside. Then you have in our next one, concave, where the diagonals are going to end up, some of them going to be outside of the polygon. So concave polygon has at least 1 diagonal with points that are going to be outside of the polygon. Okay, so looking here, the example that they are giving you is going to be these 2 lines, these 2 diagonals being drawn are formed outside of the polygon, which is the solid lines that they had there. Okay, so this here is the polygon that they are referring to, and as you can see, my 2 diagonals that are drawn are outside of that. All right, so let's look at our next page where we actually have some practice solving. And we just have, I think, yes, these 3 problems. So pretty quick. All right, so in number 1, we have find the measure of angle X. Okay, so we're going to find this angle here in the quadrilateral X, Y, Z, W. Okay, so starting off, we have that the sum of this polygon here is just going to be that 4 minus 2 times 180, which is just going to give me 2 times 180, which is 360. Okay, so we have 360 degrees total. We currently know that angle W is 100 degrees. We know that Z is going to be 90 degrees. And then we can say that we've got, I'm going to call it X plus another X is equal to 360. Okay, so I'm calling this X. Okay, and since you notice that they have marked these angles as being congruent, that means that this angle over here is also going to be X. So we can simplify. We've got 190 plus 2x is equal to that 360. When we subtract that 190 from both sides, we're going to be left with my 2x is going to be equal to 170. And therefore, dividing, we get that my x is going to be equal to 85. Okay, so the measure of angle X is equal to 85 degrees. Okay, so moving into question number 2, we are asked to find the missing angle. Okay, and so obviously my missing one is going to be this X here. Okay, what's the angle we do not know? So looking at this, we can see we've got 1, 2, 3, 4, 5 sides. So we have a pentagon. So I'm going to start off by finding my sum. So I'm going to take that 5 minus 2 times 180. Well, 5 minus 2 is just going to give me 3 times 180 is going to give me 54 degrees. So we can say that 100 plus 117 plus 105 plus 115 plus x is equal to that 540. Okay, and I'm going to combine my like terms here. So let's see. I'm going to do that off to the side. We'll say 100. Because remember, we always want to see the initial setup of what we are using for our equation. And then we can combine our like terms and everything after. So I'm going to get 10, 17. So bring my 1 over. I'll get 3 and then 4. So 437 plus that x is equal to 540. Okay, and so when I subtract that, I'm going to get that x is going to be equal to 103. Okay, and so therefore the missing angle is 103 degrees. All right, one last final problem. We have in number 3 here, 5 angles of a hexagon. So this is a hexagon. Have measures of, we've got 119 plus 129, 104, 139, and 95. I'm going to say plus x is going to be, well, remember this is a hexagon. Okay, so doing some side work over here, we're going to have 6 minus 2, my sides minus 2 times 180. It's going to be 4 times 180, which is just going to be equal to 720 degrees. All right, so real quick, before I move on any further, we do need to make note that I have not defined my variable. Okay, so I'm going to just write off to the side, let x equal missing angle. So we've defined my variable that I have randomly come up with. Now let's go through and combine our like terms. Okay, so like last time, I'm going to use some scratch work. I'm just combining them over here. All right, so 9 plus 9 gives me 18, plus 4 will give me 22, plus another 9 gives me 31, and then plus 5 will give me 36. Okay, 3 plus 1 is 4, plus 2 is 6, plus 3 is 9, and then plus 9 will give me 18. And then I will get 1, 2, 3, 4, 5. Okay, so I'm going to get 586 plus x is equal to that 720. All right, so I'm going to subtract that over. I'm going to get that x is equal to 134. Okay, so what is the measure of the missing angle? Well, my missing angle is 134 degrees. All right, so that is all we have for our lesson over our angles in polygons. Hopefully this was helpful in clearing up any questions you might have after looking at the answer keys.